constructing Pascal's triangle using binomial coefficients. And here's how we're going to do that. Let's arrange the binomial coefficients n choose k into a triangle like follows. We start with 0, choose 0, then it's 1, choose 0, 1, choose 1, and then the next row it's 2, choose 0, 2, choose 1, 2, choose 2, and then it's 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3, and so on. And in fact, this can continue as far down as we like. The recurrence relation for n choose k tells us that each entry in the triangle is the sum of the two entries above it. The entries on the sides of the triangles are always 1. This is because n choose 0 is 1 and n choose n is also 1. Again, an explanation for that is n choose 0 is 1 because there's only one way to choose 0 objects from n objects. And then n choose n on the right side of this triangle is also 1 because there's only one way of choosing n objects from n objects. All right, so using the recurrence relation and the fact that the sides of the triangles are 1s, we can actually easily replace all the entries here with the correct value of n choose k. Doing so gives us Pascal's triangle. And we can use Pascal's triangle to calculate binomial coefficients very efficiently. So I'm actually going to bring Pascal's triangle right here. It's a little small. So I'm going to move that over, and we're going to just look at Pascal's triangle here. That right there is Pascal's triangle. And so again, we can use that property that any two numbers that are next to each other, if you add them up, you get the number below it. So let's take a look at an example here. 84 plus 126 equals 210. And we can actually easily make all of these numbers. And in fact, we can, for example, find 12 choose 6 using Pascal's triangle. Namely, 12 choose 6 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all my 12 choose 0, 12 choose 1, 12 choose 2, 12 choose 3. And if we wanted to find 12 choose 6, it would be 12 choose 0, 12 choose 1, 12 choose 2, 12 choose 3, 4, 5, 6. Right there, 924. That's how we would find 12 choose 6. You don't have to use any close formulas. You can actually just easily eyeball it by just looking at Pascal's triangle. Anyways, thanks everyone, and I'll see you in the next lecture.